Hi, you might not recognize me, but I'm Old Doc Charles, and I'm here to talk about some basics of electrical engineering. This is the first set of videos in a much larger series to do with railway engineering, but I thought I'd start off with something, a bit of background. So there's this lecture in the basics of electrical engineering. And after that, I'm going to do something else. This is part one, where we're going to talk about atoms and charge, whatever that is. And there'll be more parts which will build on this. I'm trying to keep the videos reasonably short, partly because, nobody likes hour and a half videos, and I've got a bit of a short attention span, so they're going to keep them short, really. So so atoms in charge. So the first thing I'm going to talk about is the fundamental forces of the universe, and after that I'm going to talk about what electricity actually is. And then I'm going to talk about the nature of matter, and I'm going to follow this up with a little discussion on some fundamental particles, and finally I'm going to talk about charge. Now, electricity is a physical phenomenon that's tied together with kind of magnetism. So electromagnetism is one of the four fundamental forces. Originally they used to think that electricity and magnetism were actually two separate fundamental forces, but then some smart guy realized that no, it's actually two sides of the same coin. So it's electromagnetism. For completeness, other fundamental forces are, of course, gravity, which is the force that kind of pulls two masses together. It holds us here together, it holds us down on the earth and that. And it's actually quite complicated, but, we can simplify it and do some simple calculations. There's also the strong nuclear force. The strong nuclear force. And what it needs is a little reverb on that, but I haven't got any, because I'm cheap. Anyway, the strong nuclear force is kind of what holds the nuclei of atoms together. And we also have the weak nuclear force, which causes a neutron to turn into a proton by spitting out an electron and a little bit of radiation. Now, these are the only fundamental forces that we know of. There may be others that we've not discovered yet. Scientists are, working hard, even as I speak, and hopefully, they won't discover anything between the time I make the recording and the time I actually post the video, because that would be slightly embarrassing. So, moving on. So, electricity. Electricity is a physical phenomenon caused by this thing we call charge. And nuclear physics is really very complicated. But, we can take a simplified view of the universe, and that will help us understand what the hell's going on. Now, believe it or not, stuff is made from atoms. That's me, you, them, everybody. Everybody. And really, atoms are made up of three separate components. And we can think of these as balls with different properties. So electrons are very, very small black balls with a little minus sign painted on them. And they're very, very small. They're really even too small to see with a microscope or a magnifying glass. They're, practically invisible. Protons are a big red ball with a plus sign painted on it. And we also have neutrons, which are ever so slightly bigger than a proton. It's just gray. There's no discernible markings, no CE mark, no made in China or anything. It's just gray and kind of nondescript. And these markings the plus and the minus denote the electrical charge of the particle. So the plus sign is protons are positively charged, and the minus sign, electrons, are negatively charged. So the protons and the neutrons kind of, collect together in the what's called the nucleus in the middle, and the electrons kind of orbit around the nucleus in various orbits. We call these layers, or they're referred to as shells. And here we have a hydrogen atom, which is like one proton and one neutron in the nucleus, and one moon circles one electron in an orbit. Now here we have a carbon atom, slightly more complicated. There's 6 protons and 6 neutrons in the nucleus, and there's 6 electrons in 2 different layers. So the first layer, the innermost shell, has only got 2 electrons in it, and the next shell out has got the remaining 4 electrons in it. Now, the number of protons in a particular atom is fixed. If you change the number of protons, you actually change the element. So if we take our carbon atom from the previous slide and we, grab an unsuspecting proton and shove it into the nucleus, it's no longer carbon. It then becomes nitrogen and has all the properties of nitrogen. Now, each electron shell has got a limit on how many electrons can be in it. And it's all very complicated. And who decided this? So we know the inner layer can only hold 2. The next one out can hold up to 8. And then, it gets very, very complicated after that for bigger and heavier atoms. But, who decided that, the inner was going to have 2 and the next one was going to have 8 and whatever, right? So I thought, there must have been a committee somewhere that decided all this. Now, each shell wants to be full, or at least think it's full. And this is how a lot of chemistry works, is that we can confuse 2 atoms to share electrons amongst themselves and kind of join together and be happy because they think that their outer shell layer is full. This particularly works for things like silicon, in semiconductors and that, whatever they are. And I think we'll come to them eventually. And each shell layer wants to think it's full. Now, the number of neutrons in a particular atom can vary. So again, we go back to our carbon. We've got carbon with 6 protons no matter what, and we've got 6 neutrons. So that becomes the common carbon-12. You could also have carbon with 6 protons and 8 neutrons, and it then becomes carbon-14. And this carbon-14 is radioactive, and it decays, and this is how scientists can work out how old your wood is. So if you have old wood or whatever, scientists can work out how old it is. Now, neutrons really have nothing to do with electricity, and to be honest, I'm never going to mention them again. Now, most of the time, there's equal numbers of protons and electrons in an atom. And if electrons are added or taken away, then the atom becomes charged. And electricity is based on this concept of charge.
Hello.
Hello.
Here is a carbon atom that has equal number of protons and electrons. It has no overall charge. If an electron is taken away, the arrow points to the empty place. There are more protons than electrons in the atom, and it becomes positively charged. In the strive for simplicity, positively charged atoms will henceforth be shown as a single red ball with a plus sign on it. Conversely, if an extra electron is added, again with the arrow, the atom has more electrons than protons, so it is negatively charged. In the strive for simplicity, negatively charged atoms will henceforth be shown as a single black ball with a minus sign on it. So there.
Yeah, so we like simple, so we can just represent any charged atom by either a plus or a big one ball with it's either red or black with a plus or a minus on it. So that makes life much, simpler for us. Now the unit of charge is the coulomb, and the coulomb was named after Charles Augustin de Coulomb, and he lived in the 18th century. He was a French scientist. And his amazing discovery was that opposite charges attract. So if you have a negative and a positive, they will be attracted to each other. And if you have two charges the same, two positives or two negatives, they will repel each other. And for that discovery, he got the unit of charge named after him. Good for him. So it takes a lot of electrons, really, to build up an appreciable charge. A coulomb is equal to 6.242 times 10 to the 18 electrons, or protons, or lack of electrons. That's 6.2, that's a huge number with loads and loads of zeros. It's basically 6.242 billion. Now that sounds like a lot, really, but remember, electrons are very, very small, so, you could fit them in a bucket, quite easily and still have room left over for other stuff. And all of electricity is based on this concept of charge, which is created by adding or removing electrons from atoms. So it all comes down to this charge bollocks. So to recap, atoms are made of positively charged protons, negatively charged electrons, and neutrons, which have no charge. And I said I would never mention them again, but I just have, so sorry. Electrons are added or subtracted from atoms to create these charged atoms. And like Coulomb said, like charges repel, opposite charges attract. Charge is measured in coulombs, and a coulomb is 6.242 times 10 to the 18 electrons or protons. And yeah, that just about kind of wraps it up, really, for this part one. So I want to keep it quite sort of short. And yeah, join me next time for part two, when we'll expand on what we've learned here today, now, and yeah, do some other stuff. So yeah, I think that need be all. Yeah, bye, see you, bye.